Picture this. A company that sets out to absolutely dominate the future of electric vehicles. I mean, we are talking about a truly meteoric rise that takes a niche startup and turns it into an absolute automotive titan. The mission was audacious and clear, right? Scale EV production globally as fast as humanly possible. Just imagine these massive gigafactories sprouting up across continents. You've got the sprawling deserts of Nevada, massive industrial hubs in Shanghai, the forests outside Berlin. Millions of vehicles rolling off the lines every single year. It was global expansion at an unprecedented, almost breathless speed. Literally a masterclass in ambition, a physical manifestation of a company trying to build the future today.
But then came the hidden challenge that threatened everything. Behind the gleaming new cars and the soaring stock prices, there lurked this totally invisible threat. And look, we aren't just talking about a minor logistical hiccup here. We are talking about a massive, multi-front war against compounding issues. Sudden factory shutdowns, severe chip shortages, crippling shipping delays, critical battery material shortages, and mounting geopolitical tensions that threaten to just cut off entire supply routes literally overnight. Suddenly, one of the most innovative companies on the planet found itself fighting for its very operational survival against a problem that most consumers never even see.
Section 1. The hidden dependency problem. Okay, let's dive into this. To really understand how things got so precarious, we have to look at the expansion itself. Tesla aggressively pushed its operations into the US, China, Germany, and other key locations. Now, on paper, this global manufacturing network was brilliant. It was designed to slash delivery times, crush production costs, and massively increase market access. But this relentless, aggressive growth created a highly vulnerable international network. By spreading out across the globe, they weren't just acquiring new customers, they were actually acquiring new, completely hidden vulnerabilities. I want you to just think about coordinating this massive web. Building just one single electric vehicle requires thousands of interconnected components, sourced from dozens of different countries. Think about it. You are pulling lithium from mines in Australia or South America, securing semiconductors from specialized fabrication plants in Taiwan, and sourcing nickel, cobalt, and aluminum from entirely different hemispheres. Then you add in specialized battery components, complex software systems, and delicate electronic sensors. You have to coordinate all of these distinct materials across different continents, congested ports, varying regulations, fluctuating currencies, and highly volatile political environments. If your cobalt shipment is delayed by 2 weeks at a port on the other side of the planet, your factory grinds to a complete halt. The sheer volume of global dependencies required to build just one car is visually overwhelming, let alone millions of them. Have you ever considered that a missing piece of silicon, literally the size of your fingernail, could halt a billion-dollar factory? Well, this brings us to a terrifying concept in modern manufacturing, the weakest dependency. This is the single point of failure in an interconnected system that can bring everything to a grinding halt. During the global chip shortage, automotive manufacturers worldwide just completely panicked. Because if you are missing that tiny semiconductor, it absolutely does not matter if you have the chassis, the tires, and the battery ready to go. Entire massive production lines slow down. Delivery targets collapse. Billions of dollars in capital are just tied up in unfinished inventory. The more global your operations become, the more exposed you are to these exact single points of failure.
Section 2. The perfect global storm. So, if the supply chain was already a delicate high-wire act, the COVID-19 pandemic was a Category 5 hurricane. The pandemic didn't just cause a standard disruption, it exposed the deep, underlying fragility of these massive global systems. Look at how fast this cascaded into total operational panic. Days in, ports congest globally. Billions of dollars in essential inventory trapped on ships, unable to dock. Weeks pass. Factories are forced to shut down temporarily. Thousands of workers idled. Revenue halted. Months later, shipping costs sharply skyrocket as companies scramble for alternative routes, destroying profit margins. And years down the line, systemic labor shortages emerge worldwide. It was a complete cascading system failure. Even when a factory was finally ready to produce vehicles, the components simply weren't there.
The reality is brutal. Supply chains are only as strong as their weakest dependency, and here is the core vulnerability. In high-volume manufacturing, timing matters almost as much as the actual inventory itself. Having the right part just isn't enough. You have to have it at the exact right moment. If one shipment arrives late, the entire production schedule collapses. To survive this, Tesla was forced to continuously redesign logistics routes, renegotiate supply priorities, and adapt their production planning almost in real time, just to keep the lights on and the lines moving. Section 3. The battery material bottleneck. Now, beyond the immediate chaos of shipping and ships, there was a massive, long-term strategic survival issue looming: the fierce global resource war for battery raw materials. Now, what's really interesting about this slide is how these strategic risks translate directly into operational realities. Take price volatility. That guarantees unpredictable manufacturing costs. You can't price a car accurately if the cost of the materials inside it literally doubles overnight. Then you have supplier concentration, which means you are heavily reliant on highly limited sources. If 3 companies control the world's supply of a mineral, they hold all the leverage. Geopolitical exposure makes you completely vulnerable to global political tensions, and mining limitations mean the raw material supply just isn't physically there in the ground ready to be extracted at the speed required. Because without batteries there are no electric vehicles, these extreme risks push Tesla toward aggressive vertical integration. They formed direct supplier partnerships, signed long-term material agreements, and pushed really hard into internal battery innovation. They had to take control of their own destiny. Section 4. Growth versus operational control. This brings us to the core paradox of our explainer today: how massive global growth inherently becomes a massive vulnerability. Let's visually weigh these two dueling concepts. On the left side, global expansion brings incredible growth opportunities. We're talking opening up new markets, driving down costs through scale, and striving for absolute EV dominance. But on the right, look at the operational complexity it creates. You're suddenly dealing with new, often conflicting regulations across borders. You are navigating highly unpredictable local labor markets, and crucially, you face steep political risks. Imagine building a billion-dollar facility only for a sudden tariff dispute or a regional labor strike to freeze your operations indefinitely, completely out of your control. At a small scale, you can sort of micromanage these disruptions, but at a billion-dollar scale, balancing aggressive expansion with supply chain resilience is incredibly difficult. Navigating this required a very specific type of operations. Tesla is known for a high-pressure leadership style, characterized by fast decision-making, aggressive timelines, high operational intensity, and rapid adaptation. This culture allowed them to make quick, necessary pivots. For example, when their usual semiconductors ran out, they rapidly redesigned internal software systems to support alternative available chips. That is incredible operational agility. But it is also important to note that this constant rapid adaptation and pressure creates internal instability. It pushes employees to the brink, strains relationships with suppliers, and deeply tests the limits of rigid manufacturing systems. Section 5. 5 Lessons in Resilience. Tesla's survival through this gauntlet isn't just about one car company. Let's translate these survival tactics into actionable insights for the broader economy. So the crucial point is neatly packaged in these 5 steps. Let's walk through them carefully. First, efficiency without resilience is dangerous. For decades, lean, just-in-time systems were praised for cutting costs, but they are incredibly vulnerable to disruption. When you have absolutely no buffer, any delays is disaster. Second, overdependence on limited suppliers creates severe strategic risk. Diversification is mandatory. Third, even the most innovative tech companies rely heavily on physical, gritty logistics. You can have the best software in the world, but it still has to be put into a physical machine and shipped on a physical boat. Fourth, global expansion increases operational complexity far faster than most leaders anticipate. And fifth, supply chain management is no longer a background operational function. It is a top-tier strategic leadership issue that requires board-level attention. The major takeaway here is that supply chains are no longer invisible background systems. They are the front line of competitive advantage. Moving forward, the ultimate survival in business won't simply go to the fastest-growing companies or the ones with the sleekest marketing. It will go to the most adaptable. The most resilient will survive. Which leaves us with a provocative thought to end on. As you look at the landscape of modern global manufacturing and business strategy, ask yourself this: in the modern economy, is operational resilience actually more valuable than expansion itself? It is a high-stakes question that every global leader is going to have to answer. Thank you for joining this explainer, and keep questioning the systems that run our world.